Howdy, my name is Sergio Rios, and today we're going to be dealing with the MATH151 optimization problem, which goes, the U.S. Post Office will accept a box for shipment only if the sum of the height and distance around the bottom is at most 108 inches. Find the dimensions of the largest acceptable box with square top and bottom. So, thinking about this, I drew up a quick little box just to kind of get the layout of the problem. So we know that the sides on the bottom are square, so each side has the length of L and the height of H. So thinking about the perimeter that they described, 108 equals 4 times L plus H. So thinking to myself, well, we need to be able to solve for two variables, we're going to have to at least have two equations in order to be able to solve using system of equations. So due to the fact that it's going to be a square, we can use volume to find that other variable. So V equals H times L squared, given by the fact that the bottom will be a square. So using system of equations, I just use substitution. So 108 minus 4L equals H. And to solve for H, where H plugged into your volume equation is volume equals 108 minus 4L times L squared. So once you have the full equation with just one variable, we can use our derivative test to find our critical points, and then from there test for a maximum value. So using the first derivative test, we get that V prime is 216L minus 12L squared. So we set this equal to 0, and we get L 216 minus 12L equal to 0, and your crit values for your length are 0 and 18. Obviously, your max length value will be 18 due to the fact that you can't have 0 length and still be able to have a square. But just in order to prove the fact that 18 will be your maximum, I used a number line in order to test the values. So I used from 0, 18, and then onward. So I tested a value between 0 and 18 of 1, which gives you a positive value when plugged into your first derivative equation, and then a value of 20, which gives you a negative when plugged into your first derivative equation. And one of the proofs that we've learned in class is that when using a first derivative test at a critical value, if your derivative goes from a positive to a negative, then it symbolizes that critical value becoming a max. So whenever f prime goes from positive to negative, there's a maximum value, so your length is 18 at your maximum value. Using this, we can go back to our original perimeter equation, plug in L and solve for H, which 108 equals 4 times 18. You subtract the 4 times 18 in order to get H equals 36, giving your max dimensions that are your length of 18 times another length of 18 times your height of 36.